So let's compile this. Okay. So this is the basic syntax. So you have slash begin itemize, end itemize, and within that you type slash item and the corresponding entry, slash item and the next entry, and so on. Okay, so this is an unordered list. But what if you want to number them? So here you have bullets. This is a subsection, typing. Unordered list. This nesting is not necessary, but it's actually good practice. So each begin has to have a corresponding end at the same type. And so I'm making sure that they match. And then, so you just, this is something, this is called indentation if you've done programming. And it's always good practice to indent, like to have proper indentation. Okay. So how do you type ordered lists? So let's compile this. So you see, section 3.1, this is about typing unordered lists. And the next section is about ordered lists. So for this, what we have to do is we have to include a package. So let's go back to our preamble. So the stuff before the begin document is what is called the preamble. So here what I'm going to do is I'm going to use a command. So packages will add functionality. I'll include something called the enumerate package. So use package enumerate. And as we proceed, we'll be adding more and more packages. So now, like, how do we produce an ordered list? So begin enumerate and enumerate. And then within that, so this is item. This is the first entry. This is the second entry. And then lastly, you have the last entry. And let's compile this. And you see, you have like 1, 2, 3. So, but now, what if you want your numbering? Again, this is something that you can do with Word. But this is a very basic stuff. So we are starting with that too, right? And what if you want to start your numbering with, what if you want to use ABC for your numbering instead of like 1, 2, 3? So you have this begin enumerate, end enumerate, which is exactly like itemize, except here you'll have numbering. And now what I'm going to do is, I'm going to include A. Now, let's say first entry, second entry, third entry. And let's come up with it. So you see ABC. And in fact, if you can change this slightly. Yeah. And you'll get A dot, B dot, and C dot. So it's something that you can actually work with. It's quite flexible. But to use this, you have to somehow include this command here. use package enumerate. So which tells the compiler that you're going to use some commands from this package, right? Right. But now let's look at what if you want to start your numbering from, let's say, 100. So I want a list, right? And instead of starting from 1, 2, 3, I want to start from 100. So what do we do there? So you still use begin enumerate and end enumerate, but now what you have to do is you have to set a counter. And because you want to start from 100, 90. So let's say first entry, second entry, and let's compile. So this is telling the compiler that you have to start from 100. So you see, so this is the, so for some reason, for some technical reason that I'm not aware of, so you have to specify 99 instead of 100 here. So then the count starts from 100. Okay, so let's just include a comment here. Um, an unordered list. And this is an ordered list starting with A. And then the last one is, this is going to be an ordered list starting with 100. And these are just comments, okay? And so they have no effect on the output. Okay. So the next thing is, let's see how we type tabular columns. Again, a Word does this quite well, but sometimes like you'll need to produce tabular columns in LaTeX as well. So like that's why we're discussing. So what you do is you enter begin tabular. So let's say our tabular column has 3 entries. So let's go to the slides here. So what I want to do is I want to type this class list. Okay. So if you see this, what are the things that are involved here? So I have like 3 columns: serial number, name, and roll number. And then I have a caption. So how am I going to type this using LaTeX? So the first thing is, let's just produce this tabular column first, and let's worry about the class list later. Yeah. So you can see these entries, they're not that important. So you just have 3 entries, that's it. So now we have 3 columns. All of them are separated by vertical lines. And if you look at the output here, they're all centered, right? So the output here is centered. So to specify that, what I'm going to do is I'm going to include a C. The C is telling that the output has to be centered. And then a begin tabular always has to have an end tabular. And because this end tabular is not there, it is showing you a warning. Okay. So let's go back to the table here. So you see that the first thing is there is a horizontal line here, right? So let's just type this horizontal line. So for that, the command is //h_line, right? And if you once you can see it does what you expect it to do. It just draws a horizontal line, right? And then what is the next thing that we have to do? We need entries. So the first entry is serial number, name, and roll number. So serial number is the first entry. And then I want the next entry. So I have to tell the compiler that I'm going to enter the next entry. So for that, I need this and symbol or ampersand symbol. Serial number, name, and roll number. And then I have to go to the next line. So for that, I use this command, which takes us to the next line, in this tabular environment. So let's enter some random entries here. So name is Sriram and roll number is, let's say, 45. Let's include something. Let's say Badri and 65. And you want if you look at this, there is a bordering horizontal line at the bottom. So I'm typing that. And let's compile this. So we are almost there. So, but you see that if you look at, we don't have what we want, right? Because we need a horizontal line which is right below the table heading, column headings. So let's just type H line, and now we should be in good shape. Yes. So this is the table. And if you want another horizontal line between Sriram and Patri, then you can. Yeah. So you have your table, right? But then now we need a caption. So for doing this, what we have to do is we have to wrap this in like the table environment. All this nesting is not necessary, but it's good practice to follow. Yes. Okay. And now I think this is the command. Caption. So caption. And so what is this? This is a class list. Let's compile. So table class list. And for some reason, it caption is here, but if you want, you can center it. So I'm not going to go into that. Okay. So this is how, so somehow it automatically does it. But if you play around with the package, then you can probably bring this here. So this is our first table and it's a class list. Maybe you want this caption at the bottom, you can do that as well. So far we haven't talked about, this is something that you can do with Word as well, right? But we haven't talked about typing mathematical expressions. So let's go to that. So, but the real power of LaTeX is in typing mathematical expression, right? And so let's look at an example. So I want to type the following paragraph. So this is what I want to type. So the math is like ordinary, like elementary school math. So I want to type this paragraph. So suppose that A, B, C are real numbers and A is not zero. Then the roots of the quadratic equation ax squared plus bx plus c equal to 0 are given by minus b plus or minus root of b squared minus 4ac divided by 2a. So this is the thing. Remember, we're not interested in the underlying math. We just want to type this paragraph. Okay. So what are the issues that can come up when we want to type this? How are we going to type? So if you look at this paragraph here, it includes a lot of variables like A, B, C, X, parameters like A, B, C, then variables like X, right? And then also like you have plus, minus, plus, minus, square roots. And then this expression here at the end, minus b plus or minus root of b squared minus 4ac by 2a, this is a fraction. So how are we going to type fractions? Okay. So how are we going to type fractions, square roots, plus or minus, like basic operators like plus, b squared. So a lot of things here that we have to like figure out. So instead of like giving you the solution, um, let me just example. So what are the things that are easy to type here? So letters are just typing A is easy. I just use A. Okay. And the first thing that is why am I using these dollar signs? Because in LaTeX, any mathematical expression has to be typed between a dollar signs. Why? Because you're telling the LaTeX compiler that I'm going to type some math stuff. Okay. And in this case, if you want to type A, you just type A between $2. So then what else does this involve? X. You want to type X, then between two dollar signs, you type X. So let's look at this expression. Yeah. So 4AC is easy to type. You just type 4AC. It's just what you think it is. So you see A. So this A is slightly to the left because this is like the first line is always indented, but you don't have to worry about that, right? So 4AC. Then what else does this involve? Minus B. So minus B, you just type it as minus B. How about the B squared? So the B squared, so what you do here is you have, this is the symbol, B, B squared. This is how you type B squared. So you can see A, X, 4AC, minus B, B squared. Okay. So what is the next expression that we see here? You have B squared minus 4AC. So later we'll put everything together. B squared. So this is how you type superscripts, by the way. B squared minus 4AC. Okay. And after this, you have square root of b squared minus 4ac. So now what you have to do is you have to use the square root command. And over the compiler, that overleaf gives us actually like prompts us for this command. So square root b squared minus 4ac. So let's compile this. So it produces b squared minus 4ac. So this is the syntax slash square root b squared minus 4ac. So the only difficulty is you'll have to remember all these commands, but then with practice, you'll be able to do it. Then you have plus or minus. So for that, the command is slash pm. So that just gives you plus or minus. And then you have to type this minus b plus or minus root of b squared minus 4ac. Plus or minus square root of b squared minus 4ac. Let's compile this. You get minus b plus or minus root of b squared minus 4ac. And lastly, we need a fraction. So if you look at what a fraction involves, it involves a numerator and a denominator, right? So the command for typing a fraction is slash frac, and within the first pair of curly brackets, you have to type the numerator content. In this case, it is minus b plus or minus square root of b squared minus 4ac. And the denominator is just 2a. So this slash frac is telling us that we need to type a fraction, or telling the compiler that it needs to type a typeset a fraction. And see, we get minus b plus or minus root of b squared minus 4ac divided by 2. Okay. So now let's type this entire paragraph. I'm going to delete this. So suppose that a, b, c are real numbers. Remember, math expressions are usually like in italics. So you can type ABC without the dollar signs, but now the problem is that it won't be in italics, right? It will be in ordinary font. And remember, all math expressions always have to be in italics. Suppose that A, B, C are real numbers, and that A is not equal to 0. So how do we type A is not equal to 0? So it's exactly what you think it is, slash not equal to 0. Then the roots of the quadratic equation. Um, ax squared plus bx plus c. And typing equality is easy. It's exactly like what you think it is. Just type equal. There's no special command for it. Equal to 0 are given by the form. Given by uh, frac minus b plus minus square root of p squared minus 4AC divided by 2. Okay. So let's compile this. So you could see that this is a paragraph, and within the paragraph, you have some math expressions. So you have ABC and A not equal to 0, then AX squared plus BX plus C equal to 0, and then you have this minus B plus or minus root of B squared minus 4AC divided by 2A. Okay. And yeah, so that's how you do this. So the important things you have to remember is how do you type a square root and then plus or minus and not equal. And also how to type superscripts, AX squared. So AX, then you have this thing, it's usually on your keyboard above the 6. Um, so this is what you do. This is the command for typing a superscript, AX squared plus BX plus C. So let's example 1, roots of a quadratic equation. Yes. So as you can see, the important takeaway point is any math expression has to be between two dollar signs. And fractions. So the syntax of a fraction is slash frac, curly brackets numerator, and then curly brackets denominator. And typing ordinary symbols like A, B, C, etc. is quite easy because they're just available on the keyboard. Only those symbols for which like you don't have like which are not printed on your keyboard that you have to that you need commands. It's only for those symbols. Okay. So let's try to type this sentence. Right. That's our next example. So I'm sure all of you have heard of Euler's formula, right? So this section, Euler's formula. And what I want to do is type this sentence. So Euler's formula states that e to the I theta is cos theta plus I sin theta. Right? Something very basic from like complex numbers. Okay. So let's try to like what's the problem like when we try to type this formula? So we know how to type superscripts, right? We just saw that. But the main issue is how are we going to type this theta symbol? It's not there on our keyboard. Okay, so we need a command for it. So how do we type theta? Remember, theta is a Greek letter. Okay, and then how do we type cos theta and sin theta? In general, how do we type standard functions, right? Like tan, cot, secant, etc. And then Greek letters like alpha, beta, gamma. Okay, so let's see. Like we'll start with just this is one. Let's try this. It just gives you theta in English. But something similar actually works. Within the dollar signs, I put a theta. And so what I get is theta. So if I want alpha, then I have to type backslash alpha. So let's see how to type cos. So one thing you can do is type cosine theta, and let's compile this. But you see the spacing is off, right? It's completely off. There's no space. If you look at this, um, there's a space between the cos and theta here. So for that, what you have to do is include a backslash. And now we are in good shape. We get what we want. And then lastly, we need sine theta. And that's similar. Backslash line. Sine theta. And then we also need e to the I theta. So e, I need a superscript. My superscript here is I theta or exponent. So I need to type theta. So e to the I. So now let us type e to the I theta equals cos theta plus I sine theta. Yeah. So let's compile this. And we get what we want. Okay. So now we can type that sentence, right? So the sentence, what was the sentence? Euler's formula states that e to the I theta is cos theta plus I sine. So let's type this. And now let's compile this. And we have our sentence. So Euler's formula states that e to the I theta is cos theta plus I sine. How much time do I have left?
Maybe 10 more minutes, sir.
10 more minutes. So, like, so this is how you type Greek letters. So let's just see. So how would you type, suppose you want alpha. So you just type slash alpha will give you, backslash alpha will give you alpha. Similarly, gamma. Omega. So that's how you type Greek letters. So it's quite easy. So let's go to our next example. Yeah. So before that, so we've seen how to type cosine and sine, but then there are other functions as well. So there is ln, right? Log x or ln x. Then the command is exactly what you would expect it to be. Tan x, then secant, and then cosecant. Cosecant is CSC actually. So many of your standard calculus functions, what you do is you just a backslash followed by the name, and the flower within the flower brackets you have the argument. So notice that the flower brackets are actually not printed here. The curly brackets are flower brackets. So if you want to print it, you probably what you have to do is backslash. Yeah, and now it will print the flower bracket. By default, LaTeX is not going to print the curly brackets. My advice would be you just play around with it, and eventually you'll become familiar with most of these commands. Right. So now, if you look at this, like most of them are like expressions that are part of paragraphs, right? But sometimes in math, you would like to type equations separately, like just one line. Okay. So for that, we actually need a new command. So what we have done so far is we have used something called the inline math mode, right? The stuff between $2, that's like the inline math mode. But that doesn't work if we want to type equation, because equations have to be printed as separate lines, right? And uh, let's see how to do equations, how to type equations. So typing equations, you'll have to include a package, and I'm going to include something called AMS Math. So let's see, section, typing equation. And so let's look at an example here. So this is the relationship between the beta and the gamma function. Okay, if you've taken a course in special functions or an ordinary calculus course, you might have seen this form. Beta xy is gamma x gamma y divided by gamma x plus y. So let's see how to typeset this as an equation, right? Not as a part of a paragraph. So for this, what you have to do is subsection beta and gamma functions. That's the heading that I'm giving here. It's not necessary to do this. And so what you do is you include begin equation, end equation, and math content has to go within this. Okay, so now here is an important thing. So remember, like math content always has to be typed between two signs. So let's do this here, and we'll get an error. So beta xy. That's how you type beta slash beta, and then simple brackets. You just use like the symbol on your keyboard, and then you have gamma. So this is a fraction. Gamma x gamma y divided by gamma x plus y. So the numerator is gamma x gamma y, and here the denominator is gamma x plus. And let's compile this, and you're going to get an error. So the error is when you're in the equation mode, you're not supposed to include dollar sign. So the idea is that when you write begin equation and end equation, you're already in a math environment. So you actually do not need to include a dollar signs. That happens by default. The compiler understands that you're going to type math content. Okay. And another thing you notice that you can notice that this equation is actually numbered. There's a number here. Okay. So if I don't want a number, what should I do? So before I proceed, are there any questions? So you want to type an equation? The command is quite straightforward. You just need like a pair of like a begin equation and an end equation, and like within that you just type the content. And this equation is numbered. Yeah. So let's see how to type an unnumbered equation. Yeah. So this is Riemann zeta function, and let's see how to type this. And I don't want a numbering here, so let's see how to do that. But then also, like one problem here is I have to type this summation symbol. So let's see, and this zeta s. So, and also this real part of s. So how am I going to type this? And I have to type it as an equation. So what I do is begin equation. We'll come to the numbering part later. So zeta, this is the Greek letter zeta. So to type that, you have slash zeta. Then if you look at the next symbol that we have to type, we have an equal to. And then you have to type summation. So SUM. So this is the symbol for summation. Slash backslash SUM. And then if you look at what we have inside the term inside the sum, we have 1 over n to the s. But that's just a fraction. So 1 n to the s. Okay. So we are almost done. So here I need zeta s. So zeta s. Summation now. How do I type the limits? So what I do is I need a subscript here. Use this underscore command. And within the underscore, I have the subscript here is n equal to 1. Right? So that goes within these curly brackets. And then superscript is infinity. And how do I type that infinity symbol? Well, you use infinity. Slash infinity. And let's typeset this. Or let's compile it. It gives me an output. And notice that it automatically like numbers it with 2 because it recognizes that in this subsection, this is the second equation. The compiler somehow recognizes that, and so it you don't have to do the numbering manually. And if you number equations manually, there's a chance for making errors, right? Okay, but our aim is we don't want the number. So in that case, what we have to do is we have to modify this equation with equation star. And now let's compile. Yeah. So you get zeta s equals. So now you see that you don't have the number. Theta s is sigma n equals 1 to infinity, 1 over n to the. Okay. So this is if you want now, you can include some text next to your equation. This is Riemann's zeta. So the thing is, to type text within an equation, we have to use this command /text, and then whatever text you want to enter within the curly brackets. So let's include an additional space. Yeah. Okay. Right. So let's see what we can do next. Okay. And of course, this is defined only when the real part of S is bigger than E. So how are we going to type that? How am I going to type the real part? So for that, what I do is, this is the command. And let's remove this text here. This if you look at what we want here, there is some space here, and we have within that we have like real part of S is bigger than. So the spacing is a bit off. Yeah. So how are we going to include that additional space? So this is the command for it. H space, and you can specify how much space you want. Let's include like 3 millimeters. So you see, this produces some space, right? If you want, you can change this 2 millimeters. The space gets adjusted. Okay. Yeah. Something that we'll discuss in the next session is, so you have these equations, and often like in math papers and books, and in fact in scientific articles, you'll have to like refer, or like you can't keep writing the equation over and over again, right? You'll have to refer to that equation. And so in that case, you'll need to like label this and provide a link to this equation. And so we'll talk about that tomorrow. I think I have, how much time do I have? Can we stop here?
Yes, sir, we can stop here and continue in the next session, sir.
Okay, before that, are there any questions?
Participants can unmute themselves in case if they have any questions. Participants can unmute themselves if they have any questions and get it clarified.
No doubt, sir.
No.
Yeah.
Thank you so much for the enlightening session, sir.
Yeah.
I'm sure that this session will help the budding research scholars and the faculties to understand the tool LaTeX from the fundamentals. Thank you, sir, for sharing this expertise with us. I also thank the participants for their active participation in the workshop. I invite all of you to attend the second session of the workshop on Monday at 3 p.m. Thank you all. Participants are requested to fill the feedback form through the link posted in the chat box.
Thank you, sir. We'll meet tomorrow again around 3 p.m., sir, on Monday. Tomorrow will
Okay.
be a holiday.
Okay, so we're meeting on 3 p.m. At 3 p.m. on Monday.
Yes, sir. We are meeting at 3 p.m. on Monday for the second session, sir.
Okay. Okay.
Thank you,
Yeah.
sir.
Thank you.
Feedback link is posted in the chat box. Participants are requested to fill the feedback. Thank you all.
So can I log out?
Sure, sir. You can log out, sir. Yes, sir.